So we have used matrices to solve equations. There are other things we can do with them outside of just solving a system of equations. So matrices are used anytime you have a lot of numbers that you need to organize in some way. And so we can do any operations with them that we could with other variables and numbers. So we can add matrices, we can subtract matrices. We're not going to talk about multiplying matrices together yet because that is a little bit different. But adding and subtracting is pretty straightforward. One thing I want to talk about, before we can add or subtract with matrices, they have to be the same size. So when I say the same size, how did we find the size of a matrix? Rows by columns. So the first few homework questions are just going to be like, give the size of this matrix, rows by columns. There are a few special matrices. Okay, so you might have what's called a square matrix. Anyone want to take a guess what that might be?
2 by 2.
Like a 2 by 2.
Yeah, like a 2 by 2, a 3 by 3, a 4 by 4. So when the number of rows equals the number of columns. So an example, this is a 2 by 2. So if the rows and columns are equal, that is a square matrix. Okay, second special type, we could have a row matrix. Just one row. What do you think the dimensions on that are?
1 by 3.
So if you have one row, it's a row matrix. And the third special type is a column matrix. Any guesses what that might be?
Yeah.
One column. What would the dimensions of that one be?
4 by 1.
So the first few Math Excel questions are just going to be, give the size of this matrix. Is it a special type? Is it a square, a row, or a column matrix? Are we okay with that stuff? So now I just want to talk about adding and subtracting matrices. So if you just had to take a shot in the dark and guess what it is, you would probably be right. Okay, so if I gave you two matrices, A and B. First of all, they have to have the same size. What size are they?
2 by 4.
They're both 2 by 4. If they were not the same size, we would just say no solution. We could not add them together. So if I ask you to find A plus B, so if I didn't tell you how to do that, what do you think you would do?
Add the columns and rows there. Same.
Add the corresponding numbers. So 2 plus negative 3 is negative 1. 4 plus 4 is 8. 8 plus 0 is 8. Negative 3 plus 1, 0 plus 6, 1 plus 8, 2 plus 2, and 3 plus 0. Is that okay? Subtraction, it does matter what order, just like anytime if I say 5 minus 3, we know that's different than 3 minus 5, right? So let's say I said A minus B. So you just subtract the number in A minus the number in B. So 2 minus negative 3. Pencil sharpener up here. 2 minus negative.
Oh, whoopsie.
So 2 plus 3 would be
I didn't see the name.
5. 4 minus 4. 8 minus 0. Negative 3 minus 1. 0 minus 6. 1 minus 8. 2 minus 2. And 3 minus 0.
We gotta like do the whole like one in column one.
Nope.
Add all today?
Nope, not at all.
We're just doing that?
We're just doing it.
We're doing
Okay.
Alright, but give me the homework, we good.
All right, so here's your problem. So I want you to find A plus B, and
Is this all
let's
we're
do
doing
A
math
minus
Excel?
B.
Is all we're doing math Excel?
Okay.
What?
So that's where we're gonna stop for the day. My next Excel's posted.
Hold on, be patient.
We got one more to talk about that.
All right, so I'm going to put another one up here, and I'm going to ask you to do a few different calculations.
Oh, we can't do C. We can't do C. We can't do C.
Wait, no, that's easy, where you just multiply all by 4. And then the other one, you just multiply them all by 1/3.
Oh, wait, yeah.
Oh, we can do C.
Let's go.
Okay. So for A, this is called scalar multiplication. If you're just multiplying the matrix by a number, it just means you take every single entry times that number. So what would we get?
12,
4, 20, negative 8. Negative 8, 0, 24.
Yeah, that's cool.
Huh? Why'd you do 4 times 1/3? That's B you're doing, kid.
So then we're doing 1/3 C, so 1/3 times matrix C.
3, 0.
So 1/3 times 9 is 3. 1/3 times 0.
0,
Negative 1.
negative 1, and
2.
2.
3A minus 2B.
All right.
So you multiply the first one by 3, B by 2, and you subtract it.
Mm-hmm.
Oh, that's what simple as that. That's a lot of work.
All right. So you can show as much or as little work as you need to on this. First of all, are A and B the same size?
Yes.
Yes, so I can put them together. If they were different sizes, I would not be able to. If you need to write out 3A first, you can. 3A, if I take everything times 3, we get 9, 3, 15, negative 6, 0, and 18. Minus, if you take everything in B times 2, you get 8, 2, 0. Okay, that step is optional. If you don't need to write out, you don't necessarily have to. But then we're just going to subtract corresponding entries. So 9 minus 8 is 1. 3 minus 2, 15 minus 0. Negative 6 minus 16. 0 minus 2. And 18 minus negative 6. Alright. Is that one okay? Here's your problem.
That wasn't a problem?
It's all real, bro.
Alright,
You said
let's see.
16.
So negative 2a plus 7b. So negative 2 times 0 plus 7 times 4. We get 28. Is it okay if I don't write out all the work on this one?
Yes.
Okay, so negative 2 times 3, so negative 6 plus 7. Positive 10 plus 0. 10. Negative 2 minus 14. Negative 4 plus 21. Negative 12 minus 14. Negative 26.
Alright, that takes up.
Okay.
We chilling now.
The last thing I want to talk about with these is solving equations involving matrices. And it's really just solving for an unknown. So it might be that I give you something like,
Wait, what is that?
Hey. That's C. That's C1. Or is that D?
The D.
2A, B.
So no, A would be 3.
okay.
C would be 4. D would be 5. E would wait. What would
B would be 2.
E would be 2. Yeah.
E would be like.
Wait, how would E be 2?
E would be 2.
How would
E be 2?
Yeah.
E be 12.
What about?
Can I talk, guys?
Gotcha.
So if I'm asking you to solve these, we have to have all the in order for these to be equal, the corresponding entries have to be the same. So in this type of scenario, you would just be solving for all the variables. So to find A, we know 2A equals 6, so your A is 3. Okay, the next one, B is 2. Next one, D equals 5. And the next one, they were already equal. -1 equals -1, so we don't have to do anything there. The next one, we have C equals 4. And then the final one would be 3E equals 4, so E equals 4/3. So I could ask you, set up something with just 2 matrices and ask you to find the corresponding variables. Okay, is that all right with everyone?
Yes.
I might ask you to solve an equation to find a missing variable. So I might say this. So in this scenario, G is just representing a matrix. And we have to find that matrix. What would be the size of the matrix?
Column.
Be
3 by 1.
3 by 1, right? We'd have to have 3 rows and 1 column. It'd be a column matrix. So if you wanted to solve for G, what would you do?
Divide by 4.
Divide by 4. When you do that, you have to do every entry divided by 4. So you would get
2.
-3 is 16.
so that's matrix G. That makes sense to everybody? Let's try just a few more of these and then I will be done. So if I gave you this one,
J plus 6, 10, 12 equals.
so if you wanted to find J,
You just subtract it over.
you would have to subtract.
-14.
So since it was J plus this, I'll subtract that whole matrix over. So -9 minus 6,
Plus
21 minus 10, 18 minus -12, let's
No.
Almost.
Stop saying it. You're gonna make us keep doing these if you keep busting.
Is everyone okay so far?
I don't like when you said that with a smile. Oh.
I don't mean anything. It's not good.
Oh,
Nice.
subtract and divide.
Yeah, so it might be like a 2-step equation. If I am looking for this matrix, I have to get the variable m by itself. So just like any other time you solve an equation, first I would have to subtract that over. So then I'd have 4m equals, so 24 minus 5, 19, 31 minus 11, -40 minus -16, so -40 plus 16,
negative 50, or 56.
Twenty-four.
24.
Negative.
Oh.
And then what would we have to do to get m by itself?
By 4.
Divide each entry by negative 4.
So that's just gonna be negative 4.
Mhm.
Maybe fat enough. It could be 24. No,
6.
I lied.
Boom.
What?
Last one.
What? I called my notebook and everything.
Now it's not gonna be last one.
Oh, oh.
I have more if we need them.
Oh, 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 oh. No, no.
Man, chill. What?
What?
So we
Subtract it over.
No.
Or add it
When
over.
when you
Multiply,
multiply
add,
through and then subtract
divide.
it over and then you would do it.
You have two options. You can multiply that 2 through and then get it by itself. You could also subtract this over and then divide the 2. So either option will work.
Would we distribute a negative 2 or a positive 2?
You could do it either way. I would probably go ahead and distribute the negative if I were going to do that. So what do you guys want to do?
Multiply it.
Subtract 2a, 2b.
Okay.
No.
2c.
So the first option I heard was to distribute first. Since that's a minus 2, let's go ahead and just distribute negative 2. So we have negative 2a, negative 2b, negative 2c. Alright, then we again have a couple options. We can add these two together, or I could subtract this one to the other side.
Subtract it.
Subtract it.
Okay.
Negative 6.
So negative 4 minus 2 is negative 6. 3 minus 0 is 3. Negative 6 minus 8 is negative 14. So we're really just finding this matrix, but I have variables for each entry. So we need A, B, and C. How do we get A?
Divide by 2. Negative.
We know negative 2a equals negative 6, so that means A is 3. For B, we have negative 2b equals 3, so, and for C, we have negative 2c equals negative 14, so we get positive 7. So there's a math Excel assignment open and plenty of time to work.